So anyways, we're going to move on to week 4 now. Week 4 is all about active discovery. So everything we've kind of talked about thus far has been passive, where we're not making a whole lot of noise. We're not tipping off antivirus or intrusion detection systems. We're just gathering what we can. Well, now we're going to move towards some active discovery tools which are going to potentially tip off your target that you're actively engaging them. So your antivirus could go off, or the intrusion detection system or intrusion prevention system could flag your IP address that you're engaging from and shut down your engagement, and then you're kind of stuck. So we'll talk about some of the different tools that are available, and then some possibilities on how you would evade intrusion detection or antivirus if you needed to. Now, what I'm going to do to show the Nmap tool today is I'm going to fire up our Metasploitable and show you some information we need to find out about that. So if you guys want to follow along, you sure can. I had you guys install Metasploitable back in week 1. So I'm just going to turn it on here. So once it starts up here, what I'm going to do is just log in. It's MSF admin. I'm going to find out what the IP address is, and I'm going to put my Kali Linux machine on that same network. So MSF admin. So if you're not familiar with Linux, to find out the IP address, it's ifconfig. And I can see here that the IP address of this machine is 192.168.86.130. And my Kali machine is 192.168.86.129. So I'm on the same subnet. If for whatever reason you weren't, you could go up into your properties of your network card and you could change that IP address. I don't need to, so I'm good. Just to double check I have connectivity, I'm going to ping that machine. Given its vulnerabilities, it should allow ping. And I get a reply back, so I know that I'm able to communicate with my Metasploitable. So a very short slideshow here for Nmap. Talk about some of the different switches and syntax. There's some kind of deep in the weeds stuff that we need to talk about, but mainly I just want to show you what the tool is and how some of the scans work. So what is Nmap? Like it says here, free, open source. It's free, it's for me, that's my motto. So we like open source things. As we found out with some of the open source things, however, you know, there's not always the best support, that things change rapidly, but Nmap has great support. A lot of people use it. It's probably the most famous scanning tool out there. Essentially what it's going to do for you is discover hosts, devices, things on your network. It uses IP packets to determine these things. So it's going to find out what hosts are available, what services they're offering, what operating systems they're running, the versions they're running. A lot of good information that you could see would be useful for an attacker. So just along the right-hand side here, I have a quick screenshot of Nmap. And we can see that this particular machine has port 25 open, which is SMTP, port 53, which is DNS, 80 HTTP, 110 POP3, 135 MSRPC, and 139 NetBIOS. So if I'm an attacker, I know that these ports are open on the firewall or the machine. These are ones I could potentially try to exploit. As well as the ports that are open, I get to see IP address information. This particular scan didn't include it, but I could find out like what operating system it's running, what version, and those sorts of things. The nice thing about Nmap is it can run on Linux, Windows, and Mac. So any OS essentially, and there's probably even a version for your Android and Apple phones. I haven't checked. I've run it from Windows, I've run it from Linux, I've never run it from a Mac computer. So that's a huge advantage because a lot of these tools are typically Linux only, right? So being able to turn it on a Windows computer can be a great benefit. I have a couple resources there. First, there's nmap.org. If you guys go to nmap.org, this is like the official site for Nmap. Tons of information on here, almost too much, just because there's so much to sift through. You might get a little lost. Looks like version 7.6 as of this video is the latest, and it turned 20 years old on September 1st, 2017. There's some videos in here. There's some how-to sheets in here. Like I said, good reference on how to do a lot of this. You can even download the Nmap front-end GUI if you wanted to. We're going to do it through the command prompt because it's more powerful through the command prompt, so that's why. The next couple, or the next one I should say, is a cheat sheet. And I'll refer back to this maybe a couple times throughout the day here, but there's a variety of different cheat sheets you can find out there. SANS Institute has one. This one happens to be from Station X. You can find one on the actual Nmap site. I like this one because I thought it gave some good examples and was a little bit simpler. So we're new to it. Maybe you guys have used it a few times, but for most of us, we're new to it, and it gives some good syntax and some good examples on how to do things. So that's that resource. The last one here is just some YouTube results. Now, there's a ton of different Nmap scans. I've probably watched maybe 10 different ones or so. I was looking for a good one I could post up to the class. Some are really good. Some are not so good. Some expect you to have a lot of good background on it. Some start you from the very basics. So they're all kind of over the place. My goal today is to show you how it works, show you the basic syntax and some information we can get off of it. Again, most of what we're going to do in class is just kind of introducing some tools. You probably aren't going to be an expert on these things unless you spend some time outside of class working on them. Questions on any of those links? Okay, so before we can really understand how Nmap works, and again, I'm not all that concerned that you really truly understand how Nmap works. I'm more concerned that you can run a scan and interpret the results. But before you can truly understand how it works, it kind of goes back to some of the TCP/IP principles that we talked back in the 164 class, the networking class. We know that TCP is a connection-oriented protocol, which means before we initiate communication with any client using TCP, we do a three-way handshake. We verify that the host we're about to communicate is up and active and can accept transmissions. And the process that machine uses is it sends out an SYN or a synchronization message. And that's just a number. So it sends over a number. The receiving host gets that number, and he acknowledges it by adding the number +1. So it takes the number that it got, and it adds that number to it, adds 1 to that number, and sends it back over. So that's an acknowledgement. It then also sends over his own SYN message. The host on the left-hand side here gets that synchronization message and acknowledges it by taking that number and adding 1. Once we have received an acknowledgement on both ends, we now have our TCP connection up and active. This here is showing what that would actually look like if you were to sniff the traffic. So we have a TCP message, sends over the sequence number 12,952. This device gets it, and then in red here, it acknowledges it, sends over an ACK message with 12,953. So it took that number, added 1 to it, that's how it acknowledged it. It also sent over his own SYN message. Host A gets that, adds 1 to it, sends it back over, acknowledges it. Okay? When they're all done and they want to close out the session, they send over an FIN, or finish message. So the FIN gets sent over, we acknowledge the FIN, we receive that acknowledgement, he sends over his own FIN, we acknowledge the receipt of that. Okay, so these are some of the different flags that are in use with TCP. So for a lot of this port scanning that we do, especially with Nmap, the flags are going to be used to describe the status of that packet and the communication that goes with it. So the flags are bits set in the packet header, and they describe a specific behavior. TCP feature enables penetration testers or attackers to craft TCP packets designed to gain information about running application or services. So that's what we're doing, is we're using these different types of messages, SYNs or FINs or acknowledgements, to gather information from our hosts. So here are some of the common flags, and I've mentioned some of these already. The SYN, the acknowledgement, the FIN there. A few that I didn't have on those previous slides are the RST. RST is the reset bit used to clone an abnormal connection. PHS is a push data bit used to signal that the data in this packet should be pushed to the beginning of the queue. And then an urgent, or URG, data bit used to signify that there are urgent control characteristics in this packet that should have priority. Okay, so what the heck does all that mean? And again, I don't expect you guys to know about all those different flags and types. I'm just trying to give you some background on what they are, so that if you look at a certain type of Nmap scan, you have some idea of what it's doing. So what I'd like you guys to do is, before we get into these different types, is I'd like you to go to your Kali machine. So now you should have Kali up and your Metasploitable. And we're just going to type in Nmap 192. Got to remember the range here. 192, 168, 86.0. Whoops, I did a /4 with a /24. So this is just going to do a basic Nmap scan for the whole entire network of 192, 168, 80, 6.0. And your guys' might be different. You might be on a different subnet. So you'd want to figure out, by using your ifconfig, what your network you're on. But I'm on the 192.168.86.0. So anyways, I type that in, and what it's going to do at this point is it's going to go out and it's going to attempt to find all the different hosts that it can on this particular network. So it comes back and it gives me the 192.168.86.2, and it shows it has 999 closed ports. It happens to have one open port, port 53, which is DNS. That happens to be the DNS server for VMware. It also finds 192.168.86.130, which is our Metasploitable, and we can see that it has FTP, SSH, Telnet, SMTP, DNS, HTTP, and the list is very long. All of those ports or services are open and exposed. It then finds 192.168.86.254, which happens to be our default gateway, and it finds 192.168.86.129, which is our own Kali machine. So we could run that scan against any network that we wanted using that syntax, and we would find all the devices that have an IP address that are up and active on that network. Okay. Well, let's talk about some of the specific types of scans that there are. You can use an Nmap-ST, and what this is going to do, it's going to do a full connection. It's going to establish a full connection with all of the different ports with that device, and it's going to be the most reliable. It's going to also take the longest, and it's also going to be the most noisy. Because if you are trying to make all these active connections to a device or to the entire network from one IP address, that's going to be a huge red flag for an intrusion detection system or intrusion prevention system saying, hey, someone's scanning our network. All these requests, full connection requests, are coming from this one device. So if you wanted to run that one, and I'll run it just against our specific host, it would be Nmap -S capital T, and then the IP address, which was 192.168.86.130 was my Metasploitable. And it scanned that in 0.21 seconds. So if I take a look at that option, the ST, versus what I ran up top, you can see that they're the same. So that's the default behavior for Nmap, is to do that full connect type of scan. So that's a very good question. I should have mentioned that. So it's going to scan the top 1,000 used ports. Not necessarily 1 through 1,000, but the top 1,000 ports used. If you wanted to specify a specific port, you could. If you wanted to specify all ports, you could do that as well. And I'll show that here in a few minutes. We'll get through these ones here first. The -S capital S is a half open scan. So it's not going to complete that full three-way handshake. So we're not going to get a full connection. This was originally developed to be stealthy and evade intrusion detection systems. Well, what do you think happened? Intrusion detection systems caught on, right? But anyways, if I run that against the client or the Metasploitable, you'll notice that my results are essentially the same. The next one is a -S capital F. This attempts to detect a port by sending a request to close a non-existent connection. So these aren't active connections, but basically it says to the client you are scanning, hey, close this connection. And the client you're scanning is probably like, what? There's no connection to close. So it's going to return back an RST or a reset bit to signal that the port is closed. And if it doesn't return back an RST bit, it knows, hey, that port is open. This is usually only effective on Unix systems, however. We have a null scan. This is designed to send packets with no flags set at all. The goal is to elicit a response from the system and see how it responds. Okay, so that's an SN. We have an SA, which is an acknowledgement scan, attempts to determine access control list rules. So you do the SA to maybe determine some information on the security policies and settings of that device. And then the last one I have on this slide here is a -SX. This is the Christmas tree scan. This just sends packets with all different combinations of flags set. Most of them are illegal or illogical. We're just trying to see how that device responds. Those are like the most common types of scans to run. You'll typically probably run like an ST scan, that full, maybe a -SS. But if I go back to that cheat sheet site that I had open, here's some examples that I'd like to point out. This one right here, Nmap, and then a couple of IP addresses are going to scan a specific IP address. So just 2 or 3 or 4, however many you would want to decide. What we did was to use CIDR notation first to just discover the hosts on the network. You could also specify it this way, using the range, 192.168.1.1-254. Another common one the SL and the SN. So what the SL is going to do is just list the targets and not do the port scan. But the SN shows only the ones that are up. Only the ones that are up without doing the port scan. So this is more like a ping sweep, where it's just going to go out there and find all the different devices. So it found the 1 and the 2, the 130, the 254, and the 129, just like the other scan did. However, it did not list all of the open ports like the first scan that I did. It was just going out there and just discovering the hosts. Just to discover the host without doing the port scan took, I think it was 2 seconds. So about 4 times shorter, which is a lot of time actually, just to discover the hosts. So that's a popular one that you'll see out there, is just the -SN. If you want to do a -PN, that disables host discovery but does the port scan only, so kind of the opposite. Going down to the port specifications, so maybe you want to find just devices that have port 21 for FTP. You're trying to figure out what's the FTP server on the network. You can do the Nmap, the device you're trying to scan, or the network you're trying to scan, a -P for port, and then 21. Range of ports, -P, here they have 21 through 100. It's going to scan ports 21 through 100. If you want to scan multiple TCP and UDP ports, you could use the -P with the U and then the T. U colon is going to scan for UDP, T is going to scan for TCP. All ports, but if you want to do all ports, -P-. Okay, so if I go back and I do that against my Metasploitable. Here's what I found without doing -P-. Let's see if I get anything else. I don't know that we will, but it's worth a shot. And I could compare those results and see, does it have anything open that's beyond the top 1,000 most common? I'm seeing a bunch of unknowns at the end, so it did find some additional ones. So if I look at my additional scan here, or my original scan I should probably say, it found, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Real quick, I can't count very well without taking off my shoes, and it's about 30 it found the first time. Second time, -P-, about 35. So about 5 more ports it found doing that. If you want to do the top 100, you could do a -F, which is going to be a fast port scan. Okay, a couple more I want to mention here. There is the -O, which will attempt to detect the operating system. -A will do the same thing. Think of A as aggressive. This is going to do OS detection, version detection, script scanning, and traceroute. So if I do a -O scan against Metasploitable, capital O I should say, it says that it is Linux and it is Linux kernel 2.633. No, Linux 2.6.9 through 2.633. If I do a -A for the aggressive, takes a little bit longer. It's doing a lot more tasks. gives us, in my opinion, some better information than just the -O. So if time permits, and that's what you're trying to find out, the -A, in my opinion, is a little bit better. I can find the name of the machine, Metasploitable, which is what it's called. It's using Unix, Samba 3.0.20-Debian, or Debian, however you guys like to pronounce that. I can see the system time. I can see the work group it's a part of. I can do, it does the trace route, so I can see the trace route information to it. So it gives me a lot of information about that host. And as a hacker, why is that important? Why do I want to know the OS? Find out what vulnerabilities it has. Is it an unsupported OS? Are they coming out with active updates for this? Oh, they're not? Okay, that means I can use the latest exploit that's out there. Oh, this is a Windows XP machine. They haven't had an update for Windows XP since whenever it was, a couple of years ago. I automatically know by that scan that I have a vulnerable system, and now I can try to exploit it. One thing they don't have listed here, which I'll show you, is you can customize Nmap with scripts, and there's a lot of scripts that already exist out there. You can create your own, and I'm just going to show you one, and that is Nmap -- script and the banner script, and I'm going to run it against the whole 192.168 86.0 with a /24. That's the network I'm on. What the banner script is going to do for me is go out there and attempt to just get the banner information from that device. So if it's a web server, it's going to tell me what web server it's running in its version, potentially. It's going to tell me the name of the system or what platform it is. So this is going to be a lot quicker than doing the -A, the aggressive, and it can give you a lot of good information. So if I go back, or scroll up, I should probably say, it found for my Metasploitable that it indeed has port 21 open, just like all the other scans found, but I find out that it's FTPD 2.3.4. Okay, that's important to me because now I can go and look, does version 2.3.4 have any vulnerabilities? So I could hop onto Google and I could type in VS FTPD 2.3.4 vulnerabilities. And I can see here, though, it does. It has some backdoor command execution. Perfect. That's exactly what I want. I could exploit that FTP service on that host because it has a vulnerability. What else do I find out about that host? It has SSH, and it's using SSH 2.0, OpenSSH 4.7 P1, Debian-8 Ubuntu 1. Okay, so I could go do a Google search. Does SSH 2.0 OpenSSH have a vulnerability? Has Telnet open? Okay, what do we know about Telnet? Plain text, port 23. It finds it. Finds some hexadecimal information about it, which we could go interpret, I guess, if we wanted. So Banner is an excellent one to include because, again, what it's going to do is go gather some information about the versions of those particular services that are running. And if this had port 80, did this one have port 80? It did, but it didn't come back with the Banner information. But sometimes you'll see like it's running Apache version. I don't even know the latest Apache version, but it would tell you the latest Apache, or the Apache version that's on there. And if it's not the latest, you go and look and see, it doesn't have any vulnerabilities. So the -- script Banner is an excellent one to run. Okay. And one thing I probably should have done, and it was on my list, but I spaced it out, is you should move your Metasploitable and your Kali when you're running these scans to a host only. You don't want to put Metasploitable on a production network, and we really aren't. We have them through VM. But what you really should do is you should go to your settings of the VM, and you should set your Metasploitable to be host only. And then you should also set your Kali Linux to be host only. Okay, so as I said with Nmap, this is active discovery. You want to have permission before you're actively engaging with the target. You're going to start to create some noise, generate some traffic from your IP address that you're engaging from. And if they have intrusion detection, intrusion prevention, they're going to shut down your connection and you're not going to be able to connect anymore. So the next part I'm going to talk about is how you could potentially get around that. How could you get around antivirus and detection intrusion prevention systems from catching you? I have in the slides I have a list of some common port numbers, a picture of a basic scan. But the last slide is the evading active antivirus. Intrusion detection and intrusion prevention are essentially the same thing. So one thing you could do is you could fragment all of the packets that it sends from the scanner, from Nmap. You could do an Nmap dash lowercase f, remember the uppercase F was fast scan. Nmap dash lowercase f and then the IP address you're trying to scan or the network. This is going to fragment all of the packets that get sent, so it's harder for packet filters, for firewalls to pick that up. If you wanted to change the maximum transmission size and force it to be in certain number of bytes, they're 8-bit increments, or excuse me, 8-byte increments, you do an nmap-mtu and then 8 and then the IP address. So instead of sending the whole packet, it breaks that packet up into 8 bytes, which is a little bit more unusual or not as easy for the intrusion detection, intrusion prevention systems to discover. The last two are probably the best options because what you're doing is using decoys or zombies. So you can go to Nmap, or you can type in Nmap-D for decoy, and then use a random number of IP addresses, random 10, and then x.x.x.x, which would be the IP address that you're scanning. So instead of the traffic looking like it's coming directly from your Kali Linux machine, it's going to go out and randomly generate 10 IP addresses and then use those random IP addresses to send the traffic from, or make it look like the traffic is being sent from that. So to the intrusion detection system, it doesn't look like, hey, all these packets are coming from one machine. It's spread out. It's a bunch of random machines connecting, which is going to lessen your chances for that to go off. With the decoy option, you can also specify specific IP addresses. Instead of doing random, you can do an Nmap-D 192.168.1.1 and 12.12.12.12. And from those two IP addresses, it's going to send the packets from the scanner, from Nmap. Another option is to use a zombie, and the zombie would be an actual real computer. So you do an Nmap-SI, and then the target, excuse me, the zombie IP address, and then the target. So in this example, Nmap 10.10.10.1 is going to be the zombie, or the actual PC that I'm going to send the traffic off of, going to the target of 75.233.2.1. That's nice because if the intrusion detection system catches the traffic, it now thinks it's coming from someone else other than you. It's coming from this IP address. So those are some options with Nmap. We could probably spend an entire week running some scans, showing some different options. At the simplest, you could just run Nmap and then the IP or the network, and you're going to get some results. However, if you want some specific types of scans, we have all those different switches. If you want to try to evade intrusion detection and antivirus, we have those different options. What we're going to do in class is we're going to Nmap our Metasploitable, gather some information off of that, and see if we can exploit that system based on our scanning results.